Welcome to our deep dive into the world of Pieter Abbeel. You're interested in understanding his impact on robotics, and we've got this fantastic essay about his life and work to guide us. Right off the bat, there's this detail that caught my eye. Abbeel's robots can fold laundry.
Laundry folding robots, huh?
Now, you might think, okay, so, wait, but trust me, getting a machine to handle soft, unpredictable objects like clothes is a huge EE deal in robotics. It shows how Abbeel is pushing the boundaries of what we thought robots could do.
It is fascinating how a seemingly simple task can reveal so much about the complexity of AI and robotics. Traditional robots are great at dealing with rigid, predictable objects, but clothes, they're constantly changing shape, and that throws off the kind of precise programming most robots rely on.
It's like trying to get a robot used to playing chess to suddenly paint a watercolor.
Yeah.
Totally different skill sets.
Exactly.
So to appreciate just how groundbreaking Abbeel's work is, let's start with his journey. Who is this guy, and what led him to this cutting-edge field?
Well, Abbeel's story starts in Belgium. From a young age, he was drawn to math and tech. No surprise there, considering he grew up during the rise of personal computers.
Right.
He went on to study at KU Leuven, which, if you're not familiar, is a top-notch engineering school. But things really took off when he went to Stanford for his graduate studies.
Oh, Stanford.
Stanford is like the epicenter of AI research, and it's there that he really started making waves.
And I read that one of his mentors at Stanford was Andrew Ng.
Oh, yeah.
Who's pretty much a legend in deep learning. Talk about being in the right place at the right time.
Absolutely. Ning's influence on Abbeel is clear, especially in his focus on reinforcement learning, which is really the core of his work.
I know you and I have talked about reinforcement learning before.
Sure.
But could you give us a refresher for our listeners who might not be as familiar with it?
Yeah.
It's not exactly something you learn about in everyday conversation.
Of course. Think of it like this. Imagine you're teaching a dog a new trick. Every time the dog gets closer to doing the trick correctly, you give it a treat. Eventually, the dog learns to associate the action with the reward and masters the trick. Reinforcement learning is similar. You have an agent, which could be a robot, a software program, or even a virtual character in a game.
Yeah.
This agent interacts with its environment, trying different actions. Based on the outcome of those actions, it receives rewards or penalties. Over time, through trial and error, the agent learns to choose the actions that maximize its rewards.
So essentially, it's learning by doing, but with a feedback loop that guides the learning process.
Right.
But didn't Abbeel take...
That's the idea behind apprenticeship learning. Instead of being explicitly programmed, the agent learns by observing and imitating an expert.
So instead of having to program every little movement for a robot to, say, make a cup of coffee, you could just have it watch a barista do it a few times and let it figure out the steps on its own.
Precisely. This was a game changer because previously you'd need to program every single step for a robot. Imagine trying to code all the nuances of a barista's movements or a surgeon's delicate hand motions.
Oh, wow.
Apprenticeship learning allowed robots to learn implicitly, just like humans do. This made reinforcement learning much more practical for complex real-world tasks.
Which brings us back to that mind-blowing laundry-folding robot. What makes this task, which seems pretty straightforward for us humans, such a challenge for robots, even with apprenticeship learning?
It all comes down to the objects themselves. Clothes are soft, deformable, and unpredictable. They can wrinkle-fold in unexpected ways and slip out of grasp easily. This kind of variability is a nightmare for traditional robots that are programmed with rigid instructions.
It's like trying to write a computer program to predict the weather. There are just too many variables at play.
Exactly. But Abbeel's work with reinforcement learning and apprenticeship learning provided a way for robots to adapt to this complexity. And the laundry folding robot is just one example. His robots are tackling all sorts of other intricate tasks.
Like what? Give us a taste of what else these robots can do.
For instance, his robots are being utilized in surgery, assisting with procedures that require incredible precision and dexterity.
Wow.
Think about tasks like suturing or manipulating delicate tissues, things that are already challenging for human surgeons. These robots have the potential to not only assist skilled surgeons, but also to make surgical procedures safer and less invasive.
It's amazing to think that robots are already at the point where they can be trusted to assist with something as delicate as surgery.
It truly is remarkable. And that's not all. Abbeel's robots are also making waves in logistics and supply chains. They're being used in warehouses to sort and pack goods, which has huge implications for efficiency and speed in a world that demands ever faster delivery times.
So it's not just about creating cool robots, it's about applying this technology to solve real-world problems and make things better, faster, and more efficient.
Precisely. And what's really exciting is that these robots are becoming increasingly autonomous and adaptable. They're not just blindly following pre-programmed instructions, they're learning on the fly, adjusting to new situations, and even coming up with novel solutions to problems.
So they're thinking for themselves.
It's almost like that.
That's both incredible and, if I'm honest, a tiny bit unnerving. It makes you wonder where this is all heading. But before we get too far into the future of AI, I want to go back to something you mentioned earlier.
Yeah.
The challenge of bridging the gap between simulation and reality. This sim-to-real concept, can you tell us more about that?
Of course, sim-to-real is short for simulation to reality, and it refers to the process of training AI systems in a simulated environment and then transferring that knowledge to the real world. Think of it like training a pilot in a flight simulator before they ever step foot in a real cockpit. It allows you to test and refine AI systems in a safe and controlled environment before deploying them in the real world.
But I imagine there are challenges in making that leap from the perfectly controlled world of a simulation to the messy, unpredictable world of reality.
You're absolutely right. It's like training a self-driving car in a virtual city with perfectly marked roads, ideal weather conditions, and no unexpected obstacles. But then you put it on a real road, and suddenly there's a pothole, a pedestrian jaywalking, or a blinding snowstorm, things that are incredibly difficult to perfectly replicate in a simulation.
So how do you ensure that the AI system, which might be incredibly skilled in the simulation, can actually function in the real world with all its chaos and unpredictability?
That's where Abbeel's work on domain randomization comes in. It's a brilliant technique that, instead of trying to create a hyper-realistic simulation, actually embraces the chaos. Essentially, you intentionally introduce all sorts of random variations into the simulation environment.
So you're basically saying, let's make the simulation as crazy and unpredictable as possible so that the AI is ready for anything the real world throws at it.
Exactly. You might randomize things like the lighting conditions, the texture of surfaces, the behavior of other objects in the environment, even the laws of physics to some extent. For example, in a self-driving car simulation, we might randomize the friction coefficient of the road surface. This forces the AI to learn to handle a wider range of conditions, making it more robust when deployed in the real world.
It's like training for a marathon by running on a treadmill that randomly changes speed and incline. You might hate it during the training, but you'll be much better prepared for the actual race.
That's a great way to put it. And Abbeel's work in domain randomization has been hugely influential in the field. It's made sim-to-real much more effective, which in turn has accelerated the development of practical AI applications that can actually function in the real world.
This is all incredibly impressive. But with all this talk of robots doing surgery and cars driving themselves, it's hard not to think about the bigger picture, the societal impact of this rapidly advancing technology. And that's what we'll explore in the next part of our deep dive, Abbeel's vision for responsible AI and how he believes this technology can be used to benefit humanity.
Looking forward to it.
We'll be right back after a short break.
Sounds good. Welcome back to our deep dive into the world of Pieter Abbeel. Before the break, we were talking about how his work is bridging the gap between simulation and reality, bringing AI into the real world in a way that is both impressive and maybe a little intimidating.
It's like we're standing on the edge of a whole new era, and it's both exciting and a little bit daunting. But you know, one thing that gives me comfort amidst all this rapid progress is Abbeel's focus on responsible AI development. Who's not just focused on pushing the technological boundaries, he's also deeply concerned about the ethical implications of AI and how we ensure that it's used for good.
Absolutely. Abbeel is a vocal advocate for AI that is not only powerful, but also transparent and accountable.
Right.
And one of the key areas he's focused on is making AI more interpretable.
We touched on this more easily in the first part, but I'd love to delve a little deeper into this concept of interpretability.
Good.
What does it actually mean to have interpretable AI, and why is it so important, especially as AI systems become more complex and powerful?
You know, for a long time, the focus in AI research was on building systems that could achieve a certain level of performance regardless of how they got there. It was almost like, as long as it works, we don't really care how it works. But as AI systems become more integrated into our lives, making decisions that have real-world consequences, it's no longer enough to just trust that they'll do the right thing. We need to be able to understand why they're making the decisions they're making.
It's like trusting a doctor who can cure you, but can't explain their diagnosis or treatment plan. It might work, but you'd feel a lot more comfortable if you understood the reasoning behind it.
Exactly. And that's the essence of interpretable AI. It's about being able to peer into the inner workings of an AI system and understand the logic, the rules, the patterns, whatever it is that's driving its decisions. This is especially crucial in areas like healthcare finance and self-driving cars, where the stakes are high and the potential consequences of a wrong decision can be significant.
So how does one go about making AI more interpretable? Is it a matter of building AI systems in a fundamentally different way, or are there techniques that can be applied to existing systems to make them more transparent?
It's a bit of both, actually. Some approaches focus on designing AI systems from the ground up with interpretability in mind, using techniques like decision trees or rule-based systems, where the decision-making process is inherently more transparent. But Abbeel is also exploring techniques that can be applied to more complex AI systems, like those based on deep learning, which are notoriously opaque.
Can you give us an example of one of these techniques? I'm really curious to know how you can make something as complex as a deep neural network more transparent.
One technique that Abbeel has championed is called inverse reinforcement learning.
Oh, okay.
Which we briefly mentioned earlier in the context of apprenticeship learning. Remember how we talked about AI agents learning through rewards and penalties?
Yeah, it was like teaching a dog a trick with treats. The dog learns to associate the action with the reward.
Right. Well, inverse reinforcement learning flips that concept on its head. Instead of the AI agent trying to maximize rewards based on a predefined set of rules, it tries to figure out what those rules are by observing an expert.
So it's like watching a master chess player make a series of moves and trying to deduce their strategy, their underlying understanding of the game, just by observing their actions.
That's a fantastic analogy. And by understanding the underlying goals, values, and strategies that drive an expert's actions, we can start to build AI systems that align with those same principles.
Yeah.
This makes the AI's decision-making process more transparent and accountable because we can trace it back to a set of human understandable motivations and principles.
That's incredibly clever. So by figuring out the why behind an expert's actions, we can create AI systems that not only perform well, but also make decisions that align with human values and reasoning.
Precisely. And this is just one example of the innovative techniques that Abbeel and other researchers are developing to make AI more interpretable. There's a whole field of research dedicated to this, and it's an area that's only going to become more important as AI systems become more sophisticated and more integrated into our lives.
It makes you wonder if we can make these complex AI systems more transparent. Will it also help us better understand our own decision-making processes? I mean, we often make decisions without fully understanding the why behind them. Maybe AI can shed light on our own internal algorithms, so to speak.
That's a fascinating thought. And it speaks to the potential for AI to not only solve practical problems, but also to deepen our understanding of ourselves and the world around us.
Okay, so we've talked about interpretability.
Right.
But there's another challenge that's often mentioned in the context of AI research: computational constraints. Training these complex AI systems requires massive amounts of data and processing power, which can be a real bottleneck. How is Abbeel addressing this challenge?
You're right. Training advanced AI systems, especially those based on deep learning, can be incredibly resource intensive. It's not just about having the right algorithms, it's also about having the computational power to actually run those algorithms and process the vast amounts of data they require.
So is it just a matter of waiting for more powerful computers to come along? Or are there other ways to overcome this computational bottleneck?
Well, hardware advancements certainly play a role. The development of more powerful processors and specialized hardware like GPUs has been a huge boon for AI research. But Abbeel is also focused on making the algorithms themselves more efficient. He's developing new reinforcement learning algorithms that require less data and less computation time to achieve the same level of performance.
So it's like optimizing the engine of a car to get better gas mileage. You might not be able to afford a brand new superpowered car, but you can make your existing car more efficient.
That's a great analogy. And this focus on efficiency is crucial for several reasons. First, it makes AI research more accessible to a wider range of researchers and developers who might not have access to the most powerful computers. Second, it makes it more feasible to deploy AI systems in real-world settings where computational resources might be limited, like on a smartphone or a small robot. And third, it reduces the environmental impact of AI research, which is becoming an increasing concern as the field grows.
It sounds like Abbeel is really thinking about the big picture here. Not just the technological advancements, but also the accessibility and sustainability of AI.
Yeah.
It's a holistic approach that's really impressive.
Absolutely. And this commitment to making AI more accessible extends beyond just algorithmic efficiency. Abbeel is a big proponent of open source software and data sharing, which allows researchers and developers around the world to build upon each other's work and accelerate the pace of innovation. He believes that knowledge should be shared freely to benefit all of humanity, not just a select few.
It's like the open source movement in software development. By making the tools and knowledge freely available, we can collectively push the boundaries of what's possible. So we've covered interpretability, computational constraints, and the importance of open collaboration. What else is on Abbeel's mind when it comes to the future of AI? What are some of the big questions that he's grappling with? That's what we'll explore when we return.
Welcome back to our deep dive into the world of Pieter Abbeel. We've covered a lot of ground, from his groundbreaking work in robotics and reinforcement learning to his focus on responsible AI development.
It's been quite a journey.
But there's one more big question that I've been thinking about.
Oh yeah, what's that?
Well, we've talked about the challenges of AI, the need for interpretability and ethical considerations.
Right.
But what about the possibilities? What does the future hold for AI, and what role does Abbeel see himself and his research playing in shaping that future? That's a fantastic question, and one that I know Abbeel thinks about deeply. He sees AI as a powerful tool that has the potential to transform countless aspects of our lives, from healthcare and education to transportation and manufacturing. But he's also acutely aware of the potential risks and challenges that come with this technology.
So it's not just about blindly pursuing technological advancement. It's about guiding that advancement in a direction that benefits humanity as a whole.
Exactly.
It's almost like AI is this incredibly powerful force that we're just beginning to understand.
Yeah.
And it's up to us to ensure that we harness its potential for good.
That's a great way to put it. And Abbeel believes that one of the keys to ensuring a positive future for AI is fostering a strong sense of collaboration and shared responsibility. He's a strong advocate for open research and data sharing, and he believes that by working together, we can overcome the challenges and realize the full potential of AI.
You know, one thing that really struck me while reading this essay was Abbeel's emphasis on mentorship. It seems like he's not just focused on his own research, but also on nurturing the next generation of AI talent.
Yeah.
It's like he understands that the future of AI isn't just about algorithms and data sets. It's about the people who are developing and applying those technologies.
Absolutely. Abbeel is known for being an incredibly supportive and inspiring mentor. He has this knack for identifying promising young researchers and guiding them toward projects that are both intellectually stimulating and have the potential to make a real impact.
It's not just about giving them a research topic and sending them off to the lab, is it?
Right.
It's about fostering their curiosity,
Yeah.
encouraging them to ask the big questions, and giving them the tools and support they need to become the next generation of AI leaders.
Exactly. Abbeel creates a very collaborative and supportive environment in his lab at UC Berkeley. It's a place where students and researchers from diverse backgrounds can come together, share ideas, challenge each other's thinking, and work towards common goals. And many of his students have gone on to do amazing things in the field of AI, starting their own labs, founding companies, and contributing to cutting-edge research.
It makes you wonder what kind of impact one person can have if they dedicate themselves not only to advancing a field,
Yeah.
but also to lifting up others and empowering them to contribute as well. It's a ripple effect that extends far beyond any individual accomplishment.
It's a powerful legacy. And it speaks to Abbeel's understanding that building a better future with AI isn't just about writing code or publishing papers. It's about building a community, fostering collaboration, and inspiring the next generation to carry the torch.
Well, after this deep dive, I think it's safe to say that we've both become card-carrying members of the Pieter Abbeel fan club.
Absolutely. He's not just a brilliant researcher, he's a visionary leader who understands that the future of AI is about much more than just technological advancement.
Yeah.
It's about using this powerful tool to solve real-world problems, create a more equitable and sustainable future, and ultimately make the world a better place.
So as we wrap up this episode, I'd like to leave our listeners with one final thought.
Yeah.
We've talked about how Abbeel's robots are learning to fold laundry-assisted surgeries and navigate complex environments. But here's a question for you, dear listener. If you could have a robot assistant trained by Pieter Abbeel's methods, what task would you have it do? What problem would you have it solve?
It's a fun thought experiment, isn't it? To imagine a world where robots can not only handle our mundane tasks, but also help us tackle some of the biggest challenges facing humanity.
It is. And who knows, maybe one day, thanks to the work of brilliant minds like Pieter Abbeel, your AI-powered dream assistant will become a reality, And maybe, just maybe, some of our listeners will be so inspired by Abbeel's story that they'll go on to make their own groundbreaking contributions to the world of AI.
What a fantastic note to end on. It's an exciting time to be following this field.
It really is. All right, folks, that's a wrap on our Pieter Abbeel Deep Dive. We hope you enjoyed this journey into the world of AI and robotics. Until next time, keep exploring, keep learning, and keep asking those big, thought-provoking questions.